Hello everybody, I am Dr. R. Jayaseelan. In this video, I am going to talk about the fundamentals of video. Let us start with a question. What is video? Video is the technology that captures moving images electronically. Those moving images are really just like a series of still images that changes so fast that looks like the images is moving. The second question is, how does a video work? It is really very complicated to explain how a video works. But in simple terms, the lens of the camera focuses an image onto a sensor, and then the sensor converts the image into an electronic signal that is stored on tape, disk, hard disk, drive and memory card, etc. When a series of images that are displayed on a screen at fast speed, we see a perceived motion. It projects single image at fast rate, producing the illusion of continuous motion frames. The rate at which the frames are projected is generally between 24 and 30 frames per second. This is the basic way of digitalizing video signals into single image, and it is called as frame. According to many psychology studies, it is proved that 30 frames a second is good enough to stimulate smooth motion. Old movies like Charlie Chaplin were taken at 12 frames a second and visibly jerky in nature. The videos are categorized in two types. One is analog video, the second one is digital video. Let us see what is analog video. In an analog video signal, each frame are represented by fluctuating voltage signals. This is known as analog waveform. This is one of the earliest forms used for video capturing. The second one is digital video signal. Digital video actually a pattern of ones and zeros that represent the video images. Even though the data is digital, virtually all digital formats are stored on sequential tape or memory card or on disk. In digital format, each and every screen of video is made up of 1000 pixels. A pixel is a small unit of an image in which only one color can be displayed at the time. When you see television, there will be 720 vertical line of pixel from left to right and 486 row of pixel from top to bottom. A total of 3,49,920 pixel for a single frame. So every single frame will have around 3,49,000 pixels, that is 720 columns into 486 rows. To make a digital video, there are 4 factors that we have to keep in our mind. They are frame rate, resolution, color, spatial, resolution, image quality. The standard of displaying any type of non-film video is 30 frames per second. But when we take film, it falls in the category of 24 frames per second. This means that the video is made up of 30 pictures frame for every second of video. Additionally, these frames are split in half to form what are called fields. Second one is color resolution. Color resolution refers to the number of colors displayed on screen at one time. Computer deals color with RGB format, while video use a variety of formats. One of the most common video format is called YUV. YUV is a file extension of raster graphic file, often associated with color space pixel format. YUV file contains bitmap images stored in YUV format, which splits color across Y, U and V value. Y stores the brightness, U stores the color and V stores the value. Spatial resolution. The third factor is spatial resolution. In other words, how big the picture is. Spatial resolution is a term that refers to the number of pixels utilized in construction of digital image. Image having higher spatial resolution are composed with a greater number of pixels and more image detail. Since computers generally have resolution in excess of 640 by 480, most people assume that this resolution is video standard. The spatial resolution refers to the size of one pixel on ground. Temporal resolution refers how often data of same area is collected. The last one is image quality. Image quality deals with video compression. To reduce the massive volume of digital video data, compression technique with high compression ratio are required. Video compression is the term used to define a method of reducing the data used to encode digital video content. This reduction in data translates to benefits such as smaller storage requirement and lower transmission bandwidth requirement. Thank you for watching this video.